You are cruising comfortably down the interstate. The radio is playing, and your massive V8 engine decides to be smart and shut down half its cylinders to save you some fuel money. But instead of a smooth transition, the whole vehicle suddenly shudders. Your fuel economy completely tanks, and that dreaded check engine light glares at you from the dash. You pull over, plug in your Obd2 scanner, and it spits out code P3459. What you're dealing with here is a cylinder 8 deactivation or intake valve control circuit running low. To understand this, you need to know how cylinder deactivation works. Your engine control module, the EECM, basically turns your thirsty V8 into an economical V4 during light load. It achieves this wizardry by sending an electrical signal to specific intake valve deactivation solenoid, telling them to shut off the airflow to certain cylinders. In this case, cylinder number 8. When the computer senses that the electrical resistance or the voltage in this specific circuit has dropped below the normal operating threshold, it throws this code and completely shuts down the fuel injector to that cylinder to prevent catastrophic damage. This protective measure is exactly why your engine feels like it is misfiring so violently. Now, before you run to the parts store and blindly buy a new solenoid, you need to check the absolute basics. These high-tech variable valve timing systems are incredibly sensitive to engine oil pressure. If your oil level is low, or if the oil is old, thick, and sludgy, it cannot flow properly through the tiny passages that feed the solenoid. So, step 1 is always checking your dipstick and ensuring your oil is clean and topped off. If the oil situation is perfect, you need to grab your digital voltometer, DVOM, and closely inspect the wiring harness running to cylinder number 8. Because engines vibrate constantly and generate immense heat, it is incredibly common for the wire insulation to chafe away or melt, causing a direct short to the metal engine block. Unplug the connector, look for any green fuzzy corrosion on the metal pins, and run a continuity test. You want to see exactly 0 ohms of resistance on that wire. A lot of people make the extremely frustrating mistake of firing the parts cannon and replacing the solenoid immediately, only to realize later that a chewed up wire was the real culprit all along.